Good afternoon, everyone. Welcome to our session. So my name is Siong-Hu, also known as SH from Bloomberg New Energy Finance, and I cover shared mobility and autonomous vehicles in our group. So I'm sure most of you will agree with me that no conference today will seem normal. It is no mention of AI, and that's exactly what we're going to cover. So we're technically filling the gap here. And when it comes to AI, I think the first thing that usually pops up in people's head are basically chatbots and large language models. But that's basically the virtual side of AI. There's the physical side of AI as well. And the best examples today, I would say, are humanoid robots and autonomous vehicles. Now, when it comes to autonomous vehicles, I think with every passing day, we're seeing more and more autonomous vehicles, or AVs, transitioning from testing to commercial deployment. And with that, we have more challenges in terms of charging at scale and fleet operation. So those are some of the issues that we're going to address today. So I'm very happy that we have Clayton, Tino from BIP, the president and CEO of BIP, and Mark Henderson, the Chief Commercial Officer from Rocsys, to help us unpack some of the challenges as well as the solutions to deploy AVs at scale, and most importantly, address some of the underlying issues and solutions. So thank you for being here. So why don't we kick off our discussion with a brief introduction. Tell us more about yourself, your role, your company, and what specific aspect of AV or AI that you're solving right now.
Sure, happy to. So my name is Clayton Tino. I'm the President and Chief Operating Officer for BIP. Prior to that, I spent about 5 years as our Chief Technology Officer. For those of you who aren't familiar with BIP, BIP is an autonomous mobility solutions provider, which is a very convoluted way of saying that we work with public sector transportation agencies or operators and private developers to implement mobility services using autonomous vehicles. So the simplest way to think about that is we're not Boeing, we're not Airbus, but we're the airline that takes the vehicle and actually puts it into operation in meaningful use cases. From an AI perspective, we really focus on a few key areas. One is obviously safety validation from an operations perspective, number one. And then second is applications of artificial intelligence for how we manage in-cabin interactions with passengers, which is kind of a core function of what we do as an operator in the AV space today.
And I'm Mark Henderson, Chief Commercial Officer for Rocsys. Rocsys is a company that leverages a robotics platform to connect automated vehicles or autonomous vehicles to charging. So effectively, if you don't have a driver for a vehicle, when it drives up and needs to be charged, who's going to be there to charge it? We come in with an automatic connection device that grabs the charging cable and plugs it into a vehicle automatically, which helps with the infrastructure that is required for autonomous vehicles.
Clayton, I believe you have a very interesting background in aerospace engineering. Is that it? How did you get into this AV space?
Yeah, so it's kind of funny. I'm an aerospace engineer by background, did my undergraduate and PhD in kind of control theory and optimizations for aircraft control systems effectively, specializing in how you apply operations research techniques to automated air traffic control and then implement it on the control system of an aircraft. That said, I took a detour from my career for about 10 years in the cloud computing space as just a tech startup entrepreneur. From that, kind of got recruited into another startup, which was BIP. So, engineer by background, really like hard tech and deep tech problems, but I've really been an entrepreneur for my entire career to this point. And for me specifically, I think BIP was interesting because it's kind of more akin to what my background was, and I really liked the problems we're trying to solve. I mean, when we founded the company, it wasn't around, hey, can we build a better robotaxi? But we identified the fact that there are absolute use cases for larger form factor vehicles through autonomy that could help solve things like accessibility challenges for underserved communities, transit extensions, helping get people into mainline public transportation. And I think that's really where we're focusing on what we're trying to do. So being able to apply the background I have in a kind of a controls theory perspective back to a product set that I thought provided a lot of value to society potentially in the long term was something I was super interested in.
Right. And what's the origin story behind the name of the company, BIP?
I'd like to say it was something super complex, but I think we just wanted something that would stick with people. But you know what it does, though? We don't manufacture vehicles today, but in all of our communities, people don't refer to them as the shuttles or the vehicles. They say, oh, I hopped on the beep. And, it worked.
Let's bring to it. And you, Mark, what's your story? Because you have a background in what, sustainability?
I do, yeah. My background is a little bit less clear. What led me to my role right now. I studied literature and history at the University of Oregon like 40 years ago, and got involved in marketing. And through that work, I discovered sustainability for a company that did energy efficiency and demand response in support of utilities, working on how to reduce base load across the country. From there, I got an interest in electric vehicles and ran a North American team for a charging company named EVBox that was based in the Netherlands but had ambitions in the United States. Since then, I've been doing a lot of work helping companies, startups and scale-ups that need to figure out how to approach the market, but always with a sustainability bent. So energy efficiency, demand response, electric vehicles, carbon capture, battery storage, that kind of thing. And I discovered Rocsys just shy of a year ago, an organization that was very close to my house, it turned out, but also based in the Netherlands, and got really interested in what we were doing and joined as Chief Commercial Officer less than a year ago.
So what does Rocsys stand for?
It's super fancy. It stands for Robotic Charging System. That's what happens when you have 3 engineer founders get together and try to create a marketing name.
Okay. Yeah, so since we're still on the topic of EVs and charging, I'm just curious, because Rocsys is very much focused on using robotic arms to charge vehicles. How does that compare to alternatives like wireless charging or battery swapping? Do you see any competitive advantages or cost improvements in that regard?
Yeah, effectively, it's a question of what works best for whichever customer we're all targeting. Those are competitive solutions to ours. Ours uses conductive charging and connects the conductive charger to the vehicle. ChargePoint is right over here, and they're an example of a conductive charger that has charging station equipment. Something like a wireless system requires some infrastructure to be built into the ground, which requires a significant power source. There's a certain amount of line loss that happens. It's a little bit less efficient, a little bit slower charging. They do have some benefits, but they do also require each individual vehicle has to have a contact plate set underneath it. It can be pretty expensive. So what ours does is actually works with any kind of charger and any kind of vehicle and connects the two of them together. By doing that, we afford our customers a lot more flexibility. They're not locked into the asset that they've acquired, and we give them flexibility of future, so it's a lot more future-proofed. Ultimately, our system plus a conductive charger is typically less expensive, and so that's a benefit as well for the business case.
I see. So maybe I move on to Clayton here. So still sticking on the topic of EV charging, do you guys have any specific playbook when it comes to EV charging for your vehicles, as in when, where, or how you charge?
Yeah, so as I mentioned earlier, we primarily work with public transportation and kind of property developers to implement mobility services. So for us, it's largely based around the concept of operations for the service. We're not typically putting a fleet of 20 or 30 vehicles on the roadway and then having them come in, as needed. It'll typically be more like a traditional block scheduling problem where we know we have a certain discharge rate on vehicles, we know we have certain performance KPIs, be it headways, adherence to a timetable, or certain passenger throughputs we need to achieve on certain routes. So from that perspective, it's typically pre-planned with some level of buffer. We do look for things like opportunity charging, as an example, if we have lulls during service during the day, to bring vehicles back to a centralized depot to do that. I think it's an interesting question, though, as well, because one of the big challenges we have in terms of how we introduce vehicles to new service areas is ensuring that our end customers, who are the municipalities or the PTAs or PTOs or even the developers, have the infrastructure to support electric fleets. I mean, from a consumer perspective, it's getting a lot better. There are Tesla charge points everywhere. The availability of EV charging is pretty reasonable, I think, at this point from a consumer perspective. But to your point, from a power infrastructure perspective, from whether it's a specific charging endpoint requirement, that's really not standardized yet, especially for our customer base. We spend a lot of time not necessarily designing the charging strategy, but just ensuring we have the facilities and capabilities to support certain fleet sizes based on our customer requirements.
Right, and from what I understand, you guys run quite a wide variety of projects across campuses, communities, airports, and even with public transit agencies. So do you have an overarching, like, single modular solution that you apply across the board?
Yeah, we do. So again, I'm not in marketing, and the engineering team didn't name it this, but we have a software platform we call Autonomy, and it is effectively a cross-platform or ADS or autonomy agnostic solution that allows us to monitor and manage on-road AVs. And really, there are a few key value adds for us. Number one, it's a centralized ingress point for our command center in terms of how we observe on-road automated vehicles. It serves as a means for us to task and orchestrate. So if you think about, again, this may be common knowledge to folks, but when I joined the autonomy industry, so well, it's an automated vehicle, you put it on the road, it drives itself, how hard can it be? The interesting thing is until there's something telling the vehicle to go somewhere, what do you do? And I think from an autonomy perspective, most people think about Uber, Lyft, I dial a ride, it comes and picks me up. Different use cases for the public sector, though. If you think about how we manage mainline bus services, how we manage shuttle-type services, that's where our software platform focuses on as well. We have a final piece that sits inside the vehicle as well that looks at things like passenger interactions and health and safety concerns that effectively allows us, when we go driver out in certain operation scenarios, to have our remote operatives focused on what they need to be focused on as well.
Right. What's the average fleet size? Or number of passengers that a vehicle can handle?
So we focus primarily on vehicle form factors between 10 and 15 passengers. We think it's a nice sweet spot between not too small like a typical robotaxi or a single occupancy vehicle versus something bigger like a 30 or 40 foot bus.
I see.
It allows us a nice flexibility in terms of passenger throughput, price point, and our ability to operate a reasonable fleet size.
Right. And Mark, Rocsys, I think, serve quite a wide variety of vehicle form factors as well. You have terminal tractors, yard trucks in logistics, even robot taxis. So do you have different solutions for different applications, different vehicle form factors? How does it work?
Yeah, actually, our solutions are designed around the end use. Regardless of the end use, we can work with literally any vehicle that is electric. So inside passenger vehicle industry, for example, robotaxi, our system is designed to manage the charging that is needed by those vehicles when they come in, and it can be multiple vehicle types. We just have to know what they are ahead of time so we can properly integrate and commission our product once we put it on site for whichever vehicles are there. Same is true in the ports or logistics markets. If you think about a distribution center or a seaport where there's big terminal tractors driving around, they tend to be one vehicle model that they have acquired several of, and we just calibrate our system to that model ahead of time before we ship it. Then once on site, we simply commission it to make sure that it's working with the vehicle properly. But the system is actually designed for that flexibility of the architecture.
Again, on average, how many vehicles can a charger serve?
So it's important to understand that our system is a connection device between a charger and the vehicle, not the charger itself. Typically, in a logistics environment, you have around 5 vehicles to one charger or to one cable, and then in that instance, we would be one-to-one with those cables. In the robo-taxi space, it's wildly variant depending on who the customer is and what they're looking at. But we have a system where one robot arm can support up to 10 charging cables, or 10 bays, we call them, for parking and charging for the vehicles. In the ports environment, especially in the United States, there are certain environments where it's actually a one-to-one relationship between the vehicle and the charger, and that's because they're doing opportunity charging, as Clayton was just mentioning, where they really only have an hour. So all the vehicles show up at one time. During lunchtime, they have 1 hour to get a charge, and so they have to have a charger available for each and every vehicle during that lunch hour, and we work directly with one charger in that sort of situation.
Yeah, since we're at an expo, Do you happen to have a demo unit with you today?
I wish we did. We are in a industry that is highly, highly competitive between our customers. So we have several installations on site, both in Europe and the United States, mostly with ports, robotaxi, and logistics. And we have customers who have asked us to be very quiet about who we're serving. So it's a highly competitive state of affairs with these customers. It is also a really interesting competitive advantage that they're developing by working with us, because it's how they are shaving costs off their systems, and therefore they don't want us talking about who they are and what they're doing.
Okay. I'm curious though, because you mentioned that there's the ability to serve multiple vehicles per charger. So how does that work? Do you have a robotic arm, or do you use a gantry system or something like that?
Yeah, so the two different systems. So one is called single bay unit. We usually just call it S, and it's the second generation. So it's Rocsys S2 unit, and that is just one arm that is connected to the charging cable, and when the vehicle comes up, it plugs it in. We also have a multi-bay that we're developing that will be released officially next year, which is effectively a gantry system over anywhere between 6 to 10 parking stalls. And what happens with that is that the vehicle will drive up to the stall. There's an indication to our system that the vehicle is ready to be charged. There's a carriage over the top of the stalls that moves from one stall to the next, puts itself in position, opens up the flap on the car, then grabs the charging cable, plugs it into the car, and then retracts back up into the carriage that is above the parking stalls. And that way it can move back and forth flexibly between 6 to 10 bays. So if you have one parking lot that has something like 50 charging bays or parking stations, you would have 5 of our 10-bay multi-bay systems in there.
I see, interesting stuff. So I want to switch gears here and talk briefly about project lifecycle, project development. Maybe we'll start with you, Clayton. What does the project lifecycle typically look like? Do you first, because you're a B2B and B2G kind of business, you don't do any B2C, I think.
That's correct.
Okay, so how does the project lifecycle start? Like, does it start with an RFI, RFQ, and yeah?
Yeah, well, let's just skip the procurement side of it, because yeah, I mean, because that could be a very long, protracted process, and depending on kind of who the customer is, where their funding source is, the requirements are wildly different. But to your point in terms of how we go from like concept to implementation, let's look at it that way. I think the very first part of kind of any project is really development of a concept of operations. So what is the actual end use case we're looking to achieve? What is the operating environment for the target application? How many passengers are we looking to move? What is the mode of service? Is it fixed route? Is it variable fixed route? Is it something more like on-demand service? But then from there, it's really looking at the kind of desired operating characteristics of our end customer and trying to pair that with a vehicle or an ADS that has the ability to satisfy that operational domain design. So we're looking at the capabilities of the ADS itself versus the customer desire for the end application. From there, it's an assessment, right? It's a typical engineering process on paper to look at a hazard and risk analysis, usually started with data collection in the environment to look at where do we have potentially operational risks that would be introduced by a specific use case, a specific operating pattern. And then from there, it's kind of going through a full-scale deployment process. So vehicles and tires on the road, validation and mapping typically occurs as part of that, and then ultimately a clean running and validation period for, depending on the complexity of the operation, anywhere from 3 to 6 months, or as short as 2 weeks, depending on if it's a simplified use case. So again, it depends on complexities. Our project we just launched in Jacksonville, Florida, the NAVI project with Jacksonville Transportation Authority, as an example, was a 4-year project, I think, start to finish. That's part of a very large design, build, operate, maintain program. We've also done short-term demonstration programs that we've launched in 2 weeks. So again, it just really depends on complexity, scale, and what we're looking to achieve on the end stage.
Right, and when you work with a client, do they specify any key metrics for success? Like, the wait time, number of passengers?
Yeah, typically it's kind of 2 factors, I would say. First, it's passenger-facing metrics, right? So things like passenger throughput, overall ridership, system availability, and traditional transit KPIs. So are the vehicles running? Are they meeting the timetables or headways that we've prescribed? Are they available to end passengers for use? But then we also have some internal safety metrics we track as well, so required interventions, we'll say harsh or abnormal braking scenarios, anything that impact passenger safety or comfort. So it's really a two-tier model. One is just how effective is the service for the end customer, number one, and then secondly, how are we tracking towards traditional AV-based safety metrics as well.
And do you benchmark those metrics against those used in public transit today, like buses and all that?
You know, it's a really interesting question. You'd think so, but what we've learned is that the way traditional transit would approach safety is very different from an AV safety perspective. Because you have to think about the difference between how a human operates in an environment versus what a machine does. And you can get into very long, esoteric, religious, theoretical debates about, what is the right behavior for a vehicle, as an example, when it's under the control of autonomy. And it's a vastly different discussion if you're comparing what a human bus driver does in a transit context versus what the correct answer for a robot to do would be. So we try to. And the way we've approached that typically is to look at how we repackage our safety metrics and how we look at certain measures compared to things like TSI standards for bus driver behavior. And that's one way to look at it. It's an ongoing conversation with all of our customers, though, in terms of what context or what constitutes a safe operation. How do they judge and represent that when there's not a clear transition between a human service and a robotic-driven service effectively?
And what about you, Mark? Can you walk us through your project development cycle?
Yes, absolutely. So we're not the long pole in the tent for a site that is being developed. So what is important for us to understand when we engage with a customer is what is the type of vehicle that you're charging, which model is it, especially if it's in some sort of a port or logistic environment, what is the charging that you're using, and what's really important for us is actually the connector cable, because we have to grab it and hold it, and we have to program our robot to make sure that it's working properly. And then it's really important for us to understand the site design, exactly where the customer anticipates that they'll want our system to be in place. And very specifically, we can help our customer understand the best way to put that together inside their site design. Any kind of complication that really happens in development once that is all set up is usually about things that are not our system. It's about permitting timing, it's about the timing required to get the electrical upgrades, et cetera, that they need for the chargers. Our system itself is really only using 120 volt supply, so it's actually quite easy. And there's very little infrastructure kind of add that needs to happen for our system. At the same time, we do need to understand what's going on so we can get everything ready to go in a matter of 6 weeks to 2 months so that we can ship it. And then once it's shipped, we get on in there and we install the system and we commission it against operating vehicles to make sure that it's working for a time. And then once we have a certain number of successful connections in a row, we consider it fully commissioned and then we move on.
So what's a typical time frame from a project to launch? From development to testing to full commercialization, right?
Yeah, for a site, especially like if you think about a robotaxi site, or if you think about the requirements inside of a logistics, especially around the electrical infrastructure for the charging, it can take a year to a year and a half for those to get developed. Again, we're not the long pole in that tent, but we're usually part of that process. And if it's a greenfield type of operation, it's a lot easier for our customers to figure out exactly how they're going to place our system in. It's a little bit more complicated if it's a retrofit, but again, our site engineers are able to help with that pretty quickly.
Right, and is the end goal to make your system part of the fleet management system at the end of the day? And how does that work?
Yeah, ultimately our platform is designed to enable the business case of autonomous vehicles inside a depot or inside yard logistics. So our platform can be utilized for not just charging, but also for cleaning or for vehicle inspection or the like. We started with charging because that's the most urgent thing to make sure the vehicles are ready, but it's actually able to be built on to do everything else there as well. What our goal is then is to make sure that the infrastructure is set up so that the autonomous vehicle business case works well for our customers. And excuse me, in so doing, we have to engage with the fleet management system that they have chosen. Now, there's a lot of different ways that our customers are working through that. Some of them have a fleet management system that's sort of controlling everything. Some of them are just doing the individual vehicle and whatever communication they get from that individual vehicle. So we have API capability. We can patch into whatever fleet management or vehicle management system the customer is using. Or, of course, they can look at ours and leverage the platform, get the alerts, see all the reporting, et cetera, directly from ours.
Right. So staying on the topic of value chain here, I think BIP works with quite a number of AV developers like Oxa, Mobileye, and other stack. And you also work with some vehicle manufacturers like Holland and Ford Pro. So where does BIP's expertise lie actually? Are you guys only in charge of the operation piece of the business, or are you involved in the self-driving stack itself?
Yeah, so it's really two key areas. So number one is obviously on the operations side. Like I mentioned earlier, we don't build the airplane, but we are the airline. And I think what we learned, again, 6 years ago, I said this somewhat facetiously at the beginning, and I really did think it's a vehicle, it's got a self-driver, it drives itself, how hard can it be? But the reality is there's a lot that goes into taking that vehicle and putting it into a holistic operation. And we talked about a bunch right there just in terms of depot management. Pre-trip, post-trip inspections, charging, cleaning, everything that goes into maintaining a fleet is one aspect of it. But also even just identifying use case number one and what's achievable based on a number of different ADS suppliers and potentially a variety of different ADSs as implemented on a specific form factor. If you think about the simplest use case, the way you interact with a robotaxi is very differently than how you'd interact with a multi-passenger vehicle. Sharing a cabin space with multiple of the passengers who may be on different types of trips than you. So our expertise really lies first is understanding our customer use case number one and mapping that into an operational concept that makes sense for them based on the platforms we support. Secondly, from an operations perspective, it's taking those vehicles and integrating them into existing mobility networks, be it public transportation or potentially private application use cases. Lastly, I mentioned this a little bit earlier, but we do develop software that is specifically meant for the interior of the vehicle and managing passenger interactions. If you think about it, I used to work, like I mentioned, in the airlines. I've never been to a command center of any scale that didn't have a wall of TVs. And on that wall of TVs, there's at least three. One has CNN, one has Fox News, and one has ESPN, right? And all that tells me is that you're not going to get a large robo-taxi fleet and have anyone in a remote command center monitoring that many vehicles in real time, right? So we develop software that runs on the interior of the cabin using things like AI to inspect what's going on in the passenger cabin and then bring attention to our remote operators to specific vehicles and use cases of need, be it a passenger medical emergency, a fight, something that requires some sort of manual intervention. So that's really where our expertise lies. It's, again, identifying that use case, finding the best fit platform, coming up with an operational context that makes sense, and actually managing the end-to-end passenger experience in both single occupancy, multi-occupancy use cases.
So most of your vehicles still have safety attendants today? Is that so?
We do, yes, and we're actually launching our first unattended use case in the spring.
Okay. And will there be remote support then?
Yes, absolutely. So we've operated remote command centers since the beginning of the company, but this will be the transition again from that person who's now in the interior of the vehicle cabin, who frankly to this point really acts as a passenger steward, so it's answering questions, it's helping them understand what the vehicle is doing, and we'll now be transitioning those folks to our command center. What we've actually learned is that the folks suited for those command centers are actually typically the ones that started as operators on the road first. They understand the use case, they understand the nuances of the different ADS systems, they understand questions passengers have. So for us, it's been a good learning experience to start in field and now transition remotely, because we've kind of gained that tribal knowledge we can now institutionalize in terms of how we provide remote support to AVs.
Right. That's an interesting thing, because I'm thinking that for a lot of these autonomous vehicles, even though the long-term plan is to remove the driver or the safety attendant, there are specific use cases as well where you need human, to help with the passenger, maybe to remove luggages or to help those with vision or mobility impairment. So definitely that's something that's going to be around for the foreseeable future, you think?
Yeah, no, absolutely. I think one of the key areas we're focused on is accessibility in general. And I don't think anyone has fully solved that problem yet, whether it's through robotics or artificial intelligence, of how do you enable passengers of all abilities to make use of services. So again, it's a key focus of ours, not just in terms of how we provide remote support, but even in field, if we have a passenger who is unable to board without assistance, how we manage that. Absolutely.
And what about you, Mark? Does Rocsys use any remote support or on-site supervision kind of?
Yeah, not supervision per se, but we do have remote support. So once in place, properly commissioned, the system works consistently. We do have an engaged center of monitoring that takes place in our headquarters in the Netherlands. And what that is doing is we are monitoring the systems, we're getting alerts if there's a challenge, we're remotely helping troubleshoot. We can do some troubleshooting by engaging with the system and trying to determine what a challenge might be, and then we'll connect with on-site support as needed. Sometimes that on-site support is actually just provided by our customers. Sometimes it's us that can go out there and take care of something manually if needed. Ultimately, our job is to make sure the vehicle is ready when the vehicle is needed. So therefore, we provide whatever level of support is needed to make sure that the robotic system is working properly, and or we disengage the cable from it and plug in until it actually is working.
Curious though, what's the fallback plan if there's a risk of vandalism?
If there's a risk of vandalism?
Yeah.
I mean, there is always a risk of vandalism, right? So I guess we do a lot with our customers to try to define areas where we ask that people not go, or we put blockades up, et cetera. We've created systems that we believe can withstand at least some of that. If somebody wants to break our system, somebody could. That's just the way it works. So you have to really make sure that we're working with the customer to try to prevent that as best we can. One of the things I will say is we are inside depots or inside yards, right? So these are not exactly public spaces.
Challenge accepted.
So from that perspective, it's less likely. I'm not going to say it won't ever happen. It certainly can happen, or somebody, some human can intentionally break something. We will just come out there with our support people as necessary and make sure that it gets fixed quickly.
Okay, maybe we will switch gears to AI, and just to make it general, are you guys using AI in general right now to sort of improve your system, or maybe to use it for predictive maintenance or any other use cases?
Sure, yeah, I mean, we make heavy use of, I mentioned earlier, inference techniques as an example for how we monitor vehicle interiors. It's a core use case of ours. Second, we use a lot of optimization techniques, which are another form of AI in terms of how we manage the orchestration and management of vehicles within a multi-route network. Like I mentioned, we're primarily a B2B and B2G business, and one of our core value propositions, primarily on the public sector side, is how can we use automated vehicles to drive ridership to public transportation. So for us, one of the heavy uses for AI is how we actually look at routing within a given network to ultimately try to keep passengers within network. If you think about it, if you're a public transportation provider, your lifeblood is ridership. That's how you expand service, that's how you operate, that's how you provide additional modes to the constituents of your community. So for us, we want to provide the best experience we can and ultimately drive people to stay in system and not necessarily call a taxi, Uber, a Lyft, or a robo-taxi.
Yeah, and our systems are driven, and most of the IP inside of our systems is actually based on computer vision. Computer vision is a subset of AI. So the way it works is the robot arm that we've been talking about has a camera system in it, and what it's looking for is the inlet of the vehicle charge for their vehicle charging. And what that then does is it tries to learn the lighting conditions, the shadow conditions, things that might get in the way, and adjust accordingly. There are absolutely edge cases that happen that the AI can't solve, right? And then that's when we get back engaged in with our connected services providers who look at, troubleshoot things. One of the fun stories that we have that we like to tell a lot is there was an edge case that the system could not figure out what it was. What it turned out to be was a spider web caught in morning dew that had actually gotten in the inlet of the vehicle. So our people took a look at it and said, oh, look at that, there's a spider web there. And we actually wrote some new annotation that now the system can understand that's what it is and ignore it and make something happen for charging regardless of whether or not that's there, right? So it is an interaction experience based from the humans that then can help the annotation for the AI to help advance the system.
Right, so inclement weather isn't a problem. It sounds like snow fog, rain?
I mean, it certainly would be had we not been working on it for 6 years to make sure that we're able to adjust. So we can look at foggy conditions, we can look at rain, we can look at cloudy conditions versus sunshine conditions, and that's been part of the build of our system over the years.
And Clayton, any interesting edge cases that you have encountered before that you can share?
Oh, I think through that. Yeah, it's really interesting. I'll just stop with an anecdote, right? So we were looking through one of our customers. They have a passenger code of conduct, and there's a lot of language in terms of appropriate dress and what you can wear on an automated vehicle. If you think about how you have to train an AI model, you ultimately need large sets of training data. And I got a request in terms of, well, hey, how do we train models for people who may not be wearing shirts, may not have pants on? And I'm sitting here with my engineering team going, guys, this is not something we're going to entertain today. Let's just find another way to solve this problem. So you talk about edge cases in AI. If you look at things like that, which are typically off the cuff, I think it's probably the most interesting one we've encountered is how we start to train our inferencing models to look for things that may be a little off color in terms of what you traditionally look for from a training set perspective.
Right. I think we're just about out of time. But before we wrap up, is there anything we haven't touched on that you would like to add? Like, what are the next steps for Rocsys and BIP?
Yep, I'll start. For us, this is a rapidly advancing industry, especially in the robotaxi world that you've been mentioning, and we're key players in it. We're really excited about that future and what that means both for the world, but also obviously for our business, and how we can advance the use case of those things. And part of that is one of the key aspects that we provide is we can improve safety. We can avoid trips and falls. We can avoid people tripping over each other trying to get things plugged into vehicles. And so working with our customers to partner with them to understand the safety conditions required for the motion and how we fit into their landscape of their infrastructure is a really important thing for us, and but also something that we're very proud to be a part of.
Yeah, I think for us, we have a couple really exciting announcements that will become public in the next month or so regarding operations. We're starting.
That's huge.
Yeah, next quarter. And we'll also be launching services in around the Atlanta area and others in North Florida starting in Q1 next year.
Wow, definitely looking to all the new developments. So I think that's a wrap. Please join me in thanking Clayton and Mark for such an insightful session.
Thank you very much.
Let's keep in
Thank
touch.
you all.